Okay, so let's talk a little bit about that listening. It's a fascinating example of something known as expected value. Okay, Amy Duke, she never uses these words, but the strategy that she's talking about, okay, is a strategy that is actually well known to any economist or really anyone who deals with uncertainty. What Amy Duke is advising you to do is to play poker in such a way as to maximize your expected value. Okay, so we're going to go through a couple of examples of that. So first of all, what is the expected value? So the expected value is a number. It's something that can be computed mathematically in a given uncertain situation. And what it is it's the average amount that you would expect to win or lose from that situation if you were to sort of replay that situation a very large number of times. Okay, so for example, we all know that if you flip a coin, right, you're either going to get heads or tails. But the expected value of that coin flip is essentially 50-50. Okay, 50% heads, 50% tails. Obviously, if you flip the coin 4 times, is it necessarily going to be 2 heads and 2 tails? No, not necessarily. It could be 3 heads. It could be all heads. Okay, but if you were to flip that coin like 1,000 times, chances are there would be roughly 500 heads and 500 tails. Okay, so that's this concept of expected value. Okay, so let's do sort of a specific calculation. Okay, we're going to be over the next couple of slides. We're going to be learning how to calculate the expected value in a given situation. So, okay, so let's actually use a situation very similar to the one they have on the listening. Okay, so the scenario in this case is a poker situation where you have what's known as a flush draw on the river. So, so for those who don't play poker, a flush in poker is a series of 5 cards that are all of the same suit. So all diamonds or all hearts or something like that. And a flush is a pretty high hand in poker. Okay, it's a pretty good hand. So, okay, so let's say that this is a situation on the table. So in the game of Texas Hold'em style poker, you're dealt 2 cards that only you can see. And so we see this individual has been dealt a jack and a queen of diamonds. Now on the table, there is a king of diamonds and there is a 10 of diamonds. Okay, so you use the best cards between the ones on the table and the ones on your hand to sort of make up your final hand. So the upshot of this is if this next card here that gets drawn, if this next card is another diamond, well then you're going to have 5 diamonds and you're going to have a flush. Okay. There's actually, in this particular case, there's actually an even chance of having a straight flush, which is the highest hand in poker. If this next card was an ace, you would have a straight flush. But let's ignore that and just consider the flush. Okay. Okay, and let's also assume that it's 100 to call. Okay, so that is you have to pay $100 to stay in the hand, and there's already $500 in the pot, meaning that you could potentially win $500. Okay. Well, okay, as they kind of talked about the odds in the video. Okay, but since there are 14 diamonds with 4 showing, there's a 9 out of 45 chance of drawing a diamond on the last card, or 20%. Okay, so you have a 20% chance of hitting that last diamond. And so your decision can be summarized in the following table. Okay, you either hit your flush, in which case you win $500, and that happens with a probability of 20%, or 1 in 5, or you brick, and you miss your flush, somebody else wins the hand, and, pardon me, you would lose the $100 that you bet. And that's going to happen with 80% probability. Okay? And so what do you do in this situation? Well, as you sort of heard in the listening, on the one hand, you might initially think, okay, well, I only have a 20% probability of hitting this last diamond, 1 in 5. That's not very good odds. Why wouldn't I fold in that situation? And of course, what they describe in the video is, well, it doesn't necessarily mean that you should fold. It depends how much you could potentially gain if you do hit the flush, and how much you could potentially lose if you miss. Okay? And to sort of put together all of these concepts to figure out sort of overall what you ought to do, we need to calculate the expected value. Okay, so I have a link here to a Google Sheet. And this Google Sheet you're going to be using on your homework. So it's important that you pay attention how to use this spreadsheet and learn how to get this value. Okay. Part of we're actually going to be using Google Sheets a good amount in the subsequent part of the class. Part of what I'm hoping that you'll get from this is some knowledge, some basic skills on how to use spreadsheets. It's a very common skill. It's a very useful skill to have. Okay, so let's have a look at this expected value calculator that I have here. I'll actually make it a little bit bigger for you. Okay, so you can see here I have a table of values, and I have sort of plugged in the parameters or the numbers that we just talked about, right? So in this situation, we're considering two outcomes. Outcome 1 is you hit your flush, and outcome 2 is that you brick. And then those things happen with probabilities 20% and 80% respectively. Okay. Now, this column here, the utility of the payoff and the utility times probability, ignore those for now. Ignore those. Okay. And let's just pay attention to the numbers that I have here. So how do you calculate the expected value? So what you do is you take each, it's actually very simple, okay? You take each payoff, you take each amount of money that you could win or lose. You multiply by the probability of that outcome, okay? And so 500 times 0.2 is 100. Minus 100 times 0.8 is minus 80. Okay, so you do that for each of the possible outcomes. And you can see that I get these two numbers here. And then you simply add those two numbers up. So that's what I'm doing down here. This expected value is 20. Okay, so the expected value of this situation is $20. Okay, now what that means is, okay, so say you're in this situation and you play this hand. Okay, sometimes you're going to win it big. You're going to earn $500. Other times you're going to brick and you're going to lose $500. I'm sorry, you're going to lose $100. Right? So imagine doing this, like playing this hand like 1,000,000 times. Okay? Sometimes you win $500. More often you lose $100. On average, if you play this hand a very large number of times, on average you're going to make $20 every time you play. Okay? And so the expected value in this case is positive. And so if we were to go by Amy Duke's rule, if we were to go by the strategy of maximizing the expected value, you should play this hand. Okay, so now note that if I change the numbers, if I change these payoffs, I could end up changing the expected value. Okay, so for example, let's say that instead of there being $500 in the pot, so a potential upside of $500, there was only $400 in the pot. Okay, you can see in that case, I essentially break even, okay? Because we change this to a 400, now these numbers, the new expected value is 0. Okay, so this is sort of from a probability standpoint, from an expected value standpoint, this decision here, this hand, is a break-even hand. Okay, now if the reward is $300, okay, well then now my expected value is negative. Okay, and this would be a hand that I wouldn't want to play. Okay, you can sort of think about it, again, in kind of the way they were talking about it in the listening, right? For this hand to break even, for this sort of hand to be worth it, right, you would essentially need to win 25% of the time, because you would need to win, right, 1 out of 4 hands, right? Say you win the $300 on Monday, and then you lose the hand Tuesday, Wednesday, and Thursday, right? Then you would be breaking even, right? So that requires that requires you to win 1 in 4 hands. But your probability here of winning this hand is actually 1 in 5. Okay, so your probability of winning isn't quite high enough to break even. That's why we have a negative expected value here. Okay, so I hope that example makes sense. We're going to go over a couple of more examples of an expected value calculation in the next video.